Hi everyone. So today we're going to be working on finding our lowest common multiple or least common denominator. When we get to fractions, we'll call it least common denominator, but we're going to find lowest common multiples of polynomials and eventually work with fractions. So we're going to focus on how do we find those denominators if there's a variable involved. So let's focus on going back to when we first turned way back in the day about finding the least common multiple or denominator. So keep in mind that means that we're looking for the lowest number that both of the numbers will go into that are factors of. So back in the day, at least in my day, we factored down to prime factorization. So we kind of made factor trees. So 12 was like 3 and then times 4, and then we wrote that down to 3 times 2 times 2. And 30 was like 3 times 10, and we broke that down into 3 times 5 times 2. Okay, so if we want to find the LCM, we're going to take what's in common. Here they are. And we're going to write that once, because those are common factors. So we're not going to repeat them because, again, we want the lowest. So we don't want any repeats. And then these two guys, the 2 and the 5, they are going to be part of our solution because they're part of the factors of 12 and 30. So times 2 and then times 5. So that's 6 times 2 is 12. 12 times 5 is 60. Now, some of us might have been able to do that without writing out everything and writing, just knowing that 12 and 30 have a common factor or multiple of 60. Totally cool. But it's the idea of the process that I need to think about here. Okay. So I kind of borrowed this from somebody. So we're going to write the prime factorization of each denominator, in this case multiple. Select one factorization and inspect to see if it completely contains the other. If it does, that represents lowest common multiple of the denominators. If not, multiply the factorization by any factors of the other denominator that it lacks. The final product is the LCM. Okay. So let's look at this. Okay. All right. So 36, break it down. Okay, we can make a factor tree and write out the list. So I'm thinking 36. X squared is 3 and 2 for the first 6, and then 3 and 2 for another 6. And then we have 2 x's for x squared. So 24x, okay, 3 and 8. 8 is 2 and 4, and 4 is 2 and 2. Then we have an x. Okay, so let's highlight what they have in common because we don't want any extras. So here we have 3, we have a 2, and we have an x. So it's the process that we're interested in. And again, some of us might be able to do this without writing everything out, which is totally cool. All right, so we have a 3, we have a 2, we have an x. Now we're going to need everybody who is not in common. So that's the 3, the 2. Oh, wait, I missed it. I messed up. There is another 2 right here. I almost missed it. Times another 2. Okay. So here's a 3 and a 2 and an x. Okay, so we get 6, okay, times 2 is 12, times 3 is 36, times 2 is 72, and then x squared. All right, I'm just noticing that x squared and x in the original problem, and x squared is part of the LCM. Think about it. Okay, let's try this one. Okay, this one's not too bad. All right, so 15a, well, that's 3 and 5 and an a. And then 35b is a 5 and a 7 and a b. Okay, what do they have in common? They have a 5. That's it. And sometimes that happens. And then we're going to write down everything else. They don't have, A and B have nothing in common. So that's 105 AB. There we go. There's your common multiple. All right, I don't know why I started over at 1. All right, so why don't you pause the video and try like the 2 and the 2, the other 2 on the other side. Okay, so here's what I got. 180A cubed. Again, I'm noticing this. I wonder if that's a thing. Kind of processing there. All right, let's try this one. So I'm seeing that the highest exponent is our multiple for variables. Let's keep that in mind and see if it works. Okay, so these first 4 that we just did, okay, are monomials, okay, single term things, no separated by addition and subtraction, they're just multiplication happening between numbers and variables. So what do we do if there are 2 polynomials? Process doesn't change. We're still going to factor, okay, so we're going to prime factorization, we're going to factor each polynomial. Okay, so if you need to do box, split distributor, or reverse FOIL, totally up to you. Do it on the side, do your little scratch work and bring it back. So we're going to factor x squared plus 5x minus 6. Okay, factors of negative 6 that add up to positive 5 are not 3 and 2. So that's going to be x minus 1, x plus 6. Factors of x squared minus 1 are x minus 1, x plus 1. Okay, what do they have in common? They have x minus 1 in common. There's your common factor. And then so we need to write down the other 2. Okay, now we are not going to multiply these together. We're going to leave it in its factored form, because when we put these with finding common denominators for adding and subtracting, because you need a common denominator to add and subtract, we're not going to multiply them together. Okay, so we're going to leave them factored. Okay, all right, let's try. Okay, so try 3, 4, and 5. Okay, so factor. Common one only gets written once, the other guys get written. Okay, so here's 4. So x plus 3 was common. 2x minus 1, x plus 3. Yeah, you have to put the other x minus x plus 3. Okay, you only write the common one once. Even if there's another one, it needs another factor, okay? All right, let's try this one. Okay, we got a z minus 2, and then a z minus 2 and a z plus 3. Okay, now I wanted to do 6 separately because we actually have 3 here, and there's some other things going on. So we have 2 minus x. Now, that doesn't factor, but we really don't like that in the reverse there. That bothers us. Okay? So what we're going to do is we're going to take out a negative 1. We're going to take out a GCF of negative 1. Well, wait. Let's do this. Commutative property allows us to change the order in which we add things. So think of this as 2 plus negative x. So negative x plus 2. Let's factor out negative 1. Okay. All right, we have x plus 2. All right, he's nothing. We just have x plus 2. Okay. Then we have 4 minus x squared. Again, not a fan. Let's rewrite it as negative x squared plus 4. Factor out the negative 1. X squared minus 4. Now it's like, hey, I can factor that. Now I know you're probably like, well, we really didn't have to reverse them and take out the negative 1. We could have just went 2 plus x. demonstration purposes, because this does come up. We are going to need to factor out a -1 and rearrange. If it's a negative sign, if it's a plus sign, we're not going to have to worry about it. But this process of rearranging from commutative property and then factoring out the -1 is a skill that we're going to need. So, where is our common things? Our common things are going to be in the two. We're going to go in pairs of 2. It does not have to be in all 3. Okay? So I'm looking, okay, here's in common. So there's common. So we have a -1, x minus 2. And then I also see an x plus 2 here. Okay, nothing left over. There's your LCM. Okay. All right. Let me know if we have any questions. That was it, right? Yep. I can't remember how much I put on here. If you have any questions, guys, please let me know. Have a great rest of your day, and I'll talk to you again real soon.